All right, so this video is going to focus on the brain, which is the third part or piece to the nervous system. When we talk about the nervous system, we essentially have three major parts. We have the nerves, we have the spinal cord, and we have the brain. So I always kind of start with the nerves, how they function and how they work, and then keep building up. Because essentially the brain is the grandfather of everything. The brain is constantly going to monitor what's going on in the body, watching what's working, what's not working, and ultimately making the decisions on what do we need to change within our body to get back to where we need to be. So if you're running the temperature, what do we need to do to get you back to 98.6? If your blood pressure is elevated, your heart rate is up, what steps does the body need to take in order to get you back to your set points where you are going to ultimately work the best? So the brain is constantly monitoring everything that's going on in your body because we are never going to be always at 98.6. We're never going to be always at 7.4 for pH. And whenever we fluctuate, the brain is monitoring that and then figuring out what it needs to do to make sure that we don't get too far away from those set points or set values where we're supposed to be at. So when we look at the brain, the left-hand side talks about the major functions that are carried out. So those sensations, that information that those receptors are picking up, it has to figure out what to do with that. Determining perception, which is kind of a tricky thing because a lot of our perception and how we see things is based on our past experiences. So you can show the same thing to 10 different people and get 10 different reactions because their background, their experience with that could be vastly different for all 10 people. So perception is kind of an interesting thing when you start looking into that. Storing our memories, our ability to reason and process things, how we make decisions. And again, a lot of that is tied back to our past experiences. We will decide things in the present based on their experiences that we've had in the past. Regulating your visceral activities, so monitoring what's going on with your organs. Are they functioning the way that they're supposed to? And then making any corrections if they're not. And then ultimately determining your personality. Huge controversy, nature versus nurture. What is going to determine your personality more? Is it genetics? Is it your environment? Is it a combination of both? There are people that have a lot of strong opinions on that. So when we look at the brain, the major parts, you have the cerebrum, and within that you have multiple lobes. We pretty much focus on the four major lobes, which are frontal, parietal, occipital, and temporal, and we'll go into those a little bit more. Then we have the diencephalon, which is a piece at the core of the brain, the cerebellum, and then the brainstem with three parts within that brainstem. So if you go to the next slide, which shows the parts of the brain. The top picture that you have is a computer-generated image of the brain, and then the bottom one you have is an actual picture of the brain. And so just to kind of talk through some of those parts, and if you look at the left-hand side, it starts showing the skull. So you do have a layer of bone that is going to be over the surface of the brain to help protect it. And we talked about this back in our skeleton chapter, that any place in the body where you have rounded bones, those are for protection. So you can see the rounded formation immediately tells you that it is designed to protect another structure, and in this case, it is our brain. The next one that you see there is the meninges. So that is the space in which you would have those three layers. The dura mater would be right inside the skull. Then you would have the arachnoid mater sandwiched in between. And then over the surface of the brain itself, you would see that pia mater. But you can tell in that picture, there's not a whole lot of space for those meninge layers to be found. The next one that you have there is the cerebrum. The cerebrum is that layer of the brain that you have all the folds and grooves. You can see the surface of the brain is not smooth by any means. We'll talk about that a little bit more here in a minute. But that outer layer, so if you were to take off the skull and look directly at the brain, the first thing that you would see would be that cerebrum. The next one that you have there is the diencephalon. The diencephalon is a location. So you have structures within the diencephalon, but the diencephalon itself is the core of the brain, and it houses two very important parts, the thalamus and the hypothalamus. And again, this is just to kind of get a point of reference for where everything is located. I'll dive more into the structures here in a little bit. But keep in mind the diencephalon itself is a location. The structures you have within the diencephalon are the thalamus and the hypothalamus. And then we get into the brainstem. Brainstem is going to be that transition point between the brain and the spinal cord. So you will start to see that tapering where we get smaller and start to narrow. And then ultimately you will see that it becomes the spinal cord itself. So there are three parts that are going to help with that transition. The first part is going to be referred to as the midbrain. Then you have the pons, and the last one that you have on there is the medulla oblongata. So if we go over to the other side and take a look at the right, the first one that you have are these grooves on the surface of the brain. I've heard it pronounced a lot of different ways over the years. So the gyra that you have there, those are the folds, like I said. You also have the sulcus. So when we talk about those two, what we're really looking at are we're looking at the high points and we're looking at the low points. So the gyra that you have, those are the high points. So if you think of hills, top of the hills, that would be the gyra points that you have. And then the sulcus, those are actually going to be the grooves. So those are the low points. So you do have these peaks and valleys on the surface of the brain itself. And when we really take a look at that, again, intelligence and trying to find a connection between how do we know how smart somebody is. One of the things that they actually found is that the more grooves, and those are referred to as convolutions. So when you talk about the high points and the low points together, that is called a convolution. So what they actually determined is that the more convolutions you have, high points, low points, that is actually going to increase or have a connection to intelligence. More convolutions, higher IQ. And one of the things that they ultimately figured out is that when you take a look at those peaks and valleys, what it ultimately does is it increases the surface area of the brain. So if we increase the surface area of the brain, we have more places, more area to process information, and it allows for that information to be processed faster. So that is the theory behind why those convolutions are actually correlated to your intelligence. You do not want the surface of the brain to be smooth. The smoother it is, again, it's on the other side, has a direct correlation to learning challenges and issues in that regard. One of the things that they see with babies born with fetal alcohol syndrome is that is one of the telltale signs is the brain is very smooth. You don't see those convolutions within the surface of the brain. The next one that you have is the corpus callosum. The corpus callosum, very much like the spinal cord. So in the spinal cord, I showed you the sulcus and the fissure and told you that that pretty much is going to cut the spinal cord in two and give you a right and a left half. We have that same division with the brain. We do have a right and a left hemisphere. So when you're looking at this, this is a cross section of the brain. So the brain's been cut in half, we've kind of opened it up, and now we're looking at it from the side. But that corpus callosum, that is, again, that bridge between the right and the left-hand side. So that is the point where the two halves of the brain are actually connected. And that is the only point where the two sides of the brain are connected. So you have a bundle of nerves right in that corpus callosum that allow the two sides to communicate with each other. The next structure that we need to know is going to be the cerebellum. Cerebellum is basically the mini-me of the brain. It looks almost identical to the brain, but it's a much smaller version of it. And this is where a lot of our motor movements, muscle control is going to stem from, is from that location of the brain. And then the last one that you have is the spinal cord. So kind of going back to that brain stem, the midbrain, the pons, the medulla oblongata. You can see ultimately when you get to the end of that, we have now transitioned into the spinal cord. And you can see on the right and the left-hand side, the vertebrae that are helping to support and protect that spinal cord. If you move to the next slide, it talks about the brain ventricles. So this goes back to our cerebral spinal fluid in the fact that you need to have areas for that cerebral spinal fluid to be able to get to all the parts of the brain itself, especially trying to get to those neurons, because we're really trying to take care of them, make sure that they are getting the nutrition they need, making sure that they are getting all of the ions that they need so that they can send impulses. And so the ventricles are basically this built-in system that allows for space for the cerebral spinal fluid to travel. So it's these corridors that are going to get into the different parts of the brain so that cerebral spinal fluid is constantly flushing through the system. So there are 4 total ventricles that we have. Sometimes they are given numbers, 1, 2, 3, and 4, and sometimes they are given just names. So 1 and 2 are going to be referred to as your lateral ventricles. You would have one in the left and one in the right hemisphere of the brain. And you can see that in the picture, the top picture. It only refers to or draws a line to the one on the right, but obviously you have a counterpart on the left-hand side as well. They kind of look like horns in there, or quotation marks. But those are going to be the ventricles that are going to be in the right and the left hemisphere of the brain. Then you have the third ventricle, and that is going to be right at the core of the brain. So where the right and the left hemisphere meet, you would have that third ventricle that would be right at the core of everything, and essentially connects the 2 lateral ventricles. And then you have the fourth one, which is going to be on point with where your brain stem is. And so that is going to help maneuver it down the spinal cord. And again, like I said, you have that complete system of cerebral spinal fluid working through not only the brain, but the spinal cord as well. The bottom picture you have gives you a little bit different view of those ventricles and just how far reaching they are to be able to get CSF to all the different parts of the brain. The next slide that you guys have, and I actually want you to pay attention to the next 2 slides because they go hand in hand. The first one that you have with the lobes of the brain just gives you a picture of where they are. So you have the frontal one, which is going to be on point with your forehead. You have the parietal, which is going to be the upper part of your skull. You have the temporal, which is on point with your ears. And you have the occipital, which is on point with the back. So if you think back to the names of the bones that we had in our skeletal chapter, they should sound very familiar because that is the exact same name of all the bones that are protecting those lobes. So they do go hand in hand. If you look at the following slide, it gives you a little bit of background on what each one of those lobes is actually going to do. So when you think about that frontal lobe, if you look at the table, this is really where a lot of your higher level thinking and reasoning skills are going to come from. So the interesting thing about that is when you talk about the frontal lobe and higher level thinking, being able to figure out problems, being able to do cause and effect. If I do this, what could potentially be the outcome? And being able to make all those kind of determinations, that is actually the last part of our brain to fully form. And some people have heard about this before. It's different for the genders, and it's actually scientifically proven. But for females, it usually happens late teens, early 20s, where that part of the brain will fully form. For guys, it tends to be a little bit later, early 20s to mid 20s. And the reason for that is actually testosterone. Because men have higher levels of testosterone, for some reason, that impacts the development of that brain, that portion of the brain, and that's why we see it take a little bit longer. Females have a lower amount of testosterone, and so that part of the brain is able to finish off a little bit earlier. There's been so much research on this, in fact, that they actually, car companies will charge higher rates of insurance for men until they hit the age of 25 because of what that part of the brain is tied to and how that connects or links to driving and decision making. The parietal lobe, when you look at what the parietal lobe is going to be for you, remember that's going to be the higher side, the sides of the brain. This is going to deal with different types of sensation, so temperature, hot, cold, touch, pressure, vibration, and then any sort of pain information that is coming in from those receptors that you have within your skin. It also, if you look at the bottom one, talks about your ability to understand speech, but it even goes a little bit further with that. And the last one I think is important because it is going to also correlate with your thoughts and your feelings. And again, that is going to link back to experiences you had very early on in life. So when you first start having the ability to make memories, you are going to tie your thoughts and things like that back to those early years. So those are really formational years, very important because it ultimately will impact how you decide things, how you process information later on in life. Temporal lobes, because they are on point with your ears, it's usually a pretty easy connection that is going to tie or link into your hearing. But then also on the sensory side of things, that it's also going to help with your ability to make visual connections between things that you are seeing and you're hearing. So if you've ever heard a song and you start to visualize something, you could see kind of a scene playing out in your head. Not that you're watching TV and it's on the TV, but you just hear the music and it triggers a thought in your head. That is going to be done within the temporal lobe. And then the last one, the occipital lobe, again, location, occipital indicates vision. And this is a little bit harder stretch or connection for people to make because we think of our eyes being in the front, and now we're talking about occipital and that being processed in the back. The reason for that kind of separation between where our eyes are is because we need to have time to process the visual information that is coming in. So the optic nerve that extends out of the back of your eye and then ultimately will crisscross as it moves to the back of your brain, that space is going to give you time to process that visual information as it's coming in. So we need to have that distance between where the eyes actually are and the part of the brain that will process that information for us. It's also why if you ever get cracked in the back of the head, you might see those little starbursts, because when you got hit in the back of the head, it triggered that occipital lobe, which is trying to process visual information. You didn't have any visual coming in with whatever struck you in the back of the head. So your brain is trying to take that energy from getting struck and turn it into something. It doesn't have a visual to put with it, and so you get those little starbursts or color bursts instead. The next one talks about the diencephalon, and this is the one that I was referencing earlier, in that the diencephalon itself is a space. And within that space, you house two very important parts, the thalamus and the hypothalamus. So the thalamus itself is going to be essentially a place to process information as it comes in. So we have these special places in our brain that are going to process visual things, are going to process auditory things, are going to process language and all of that. It's very, very important that when that information comes into the brain, it gets directed to the right location. And so that is the job of the thalamus. It's kind of like a receptionist. If you go into an office building, you're not really sure what office you're looking for, you stop at the receptionist and tell them, and they will direct you to where you need to go. Same exact thing with the thalamus. That sensory information comes in, the thalamus is going to take a look at that sensory information, and then it's going to direct it to the part of the brain where it is going to be able to be interpreted and figured out. The other part of the diencephalon is going to be the hypothalamus. The hypothalamus, if you look at the name hypo, you guys are aware that hypo indicates below. And so in positioning, the thalamus is on top, the hypothalamus is tucked underneath. So that is the reason for the name. I'm just telling you position-wise where it is. But the hypothalamus is going to do something very different. Hypothalamus is going to deal with those things that deal with homeostasis. So making sure that your blood pressure is on point, making sure that your heart rate is where it needs to be. It's going to monitor your pH levels. And it's going to just make sure that all of those are staying within the limits that they need to be within for you to function. And if not, it's going to send information to the brain that things are getting too far away from set point where they need to be at, and that the brain needs to start doing a series of actions to get it back to where it needs to be. The last slide that you guys have is going to focus on the brainstem itself. And so with this particular picture, you'll notice that you have kind of just that corpus callosum, so you can see where that is. The rest of the brain has been removed from the picture. And then you have the three parts of the brainstem. First one is going to be the midbrain, and then you have that bulge that is in the middle, which is the pons, and then you have the last one, which is the medulla oblongata, before you ultimately get into the spinal cord itself. So positioning wise, just understanding that they are in very specific locations. It's not just like they're all bundled in there together. But that midbrain is going to be the first part that you have. The pons is going to be tucked underneath, and then the medulla oblongata is the final one that you will have before you get to the spinal cord. In this picture, you can also see the location of the thalamus and the hypothalamus. So you get that division of the thalamus being slightly higher, the hypothalamus being tucked underneath that. And then just above the word midbrain, you have a tiny little structure there. We haven't talked about it yet. It's a chapter for second semester, but just to kind of, again, give you reference, that is your pituitary gland. And we will spend a lot of time, especially when we get into our endocrine chapter, talking about the pituitary gland, because despite how small it is, it actually does a lot of different things for the body. So that is the brain portion of our conversation. Within the next 2 weeks, you will need to complete both videos and then make sure that you take a look at the assignments and get that done and bring it to our final meeting. Our final meeting, while I'm not going to introduce any brand new information, the activities that tie to the spinal cord and to the brain, as well as with the nerves, we're going to pull those in. So even though it's not going to be heavy on lecture by any means, but we are going to work all of those lab activities into that day, as well as a review to kind of help pull back some of that muscle information, and cover that a little bit closer to the time that you actually are going to be taking your final, which will be our last meeting.